Good morning to you all. My name is Rosalia Malundilange, and my contact details are as shown on the screen. I'm taking you through mathematics, which is a degree level, year 1. Firstly, we'll look at the order of operation. When we think of the order of operation, we always think of BODMAS. In mathematics, we have moved, and now we are using BEDMAS. No longer BODMAS, but BEDMAS or PEDMAS. BEDMAS and PEDMAS are the same things. The difference is just the B and the P, and the B and the P is either B for bracket or P for parenthesis, which is another name for brackets. And then the O has moved out because O was off, which is multiplication, but we did not take into consideration cases where we have exponents. So the exponents that we can also call powers or index can also be taken care of with BEDMAS or PEDMAS. The rest of the things remain the same: D for division, M multiplication, and the list goes on. Now remember, whenever you are given an expression, you should follow BEDMAS or PEDMAS. You start with the brackets, solve any exponents if there is, then follows divisions, multiplication, addition, and subtraction. Okay? Remember to follow BEDMAS starting from the left to the right. We move on to fractions. Fractions is used to represent a part of a whole. It consists of a numerator and also a denominator. There's 3 types of fractions. We have proper fractions, improper fractions, and mixed fractions. Where proper fractions, the numerator is greater than the denominator. Improper fractions, the numerator is greater than the denominator. And in mixed numbers, you have a whole part and then a fraction part. Okay? Proper numerator is smaller than the denominator. Improper numerator greater than the denominator. And mixed fraction, you have a whole part and then a fraction part. When it comes to addition of fractions, the denominators of the fractions that are being added have to be the same. Now, how do we make the denominators to be the same? Just multiply the first fraction with the numerator of the second one and multiply the second fraction with the numerator of the first one. Now remember, when you are multiplying the first fraction or the second fraction with the denominator of the first or the second, whatever you do to the numerator, do it to the denominator so that you don't change the equations. Okay? What I just said is shown on the screen right now. We have 3/4 plus 2/7. The denominator of the first fraction is 4. So you multiply 4 with the fraction with the second fraction. So the 4 will be multiplied with a 2 and also with a 7. And then you multiply the first fraction with the denominator of the second one, which is 7. So the 7 will multiply the numerator of the first one, which is 3, and the denominator of the second one, which is 4. And then when you get your answer, make sure to leave it in the simplest form. See if there's any number that can go into both the numerator and the denominator without leaving a remainder. Okay? Now here on the second example, we have mixed numbers. I have seen that most of you have problems on how to change mixed numbers to improper fractions. What you do is you multiply the denominator with the whole number part and then add the numerator, and then the denominator remains the same. When you make it when you change it to improper, then make sure the denominators are the same by remembering this, the simple rule of multiplying the first fraction with the denominator of the second one and the second fraction with the denominator of the first one. When you multiply these two denominators, the result that you get is called a common denominator. When it comes to subtraction of fractions, the same thing applies. Okay? Let me quickly go back. Okay? When it comes to subtraction, the steps that you need to take is almost the same as the the ones in addition or fractions, the denominators still has to be the same. Now the denominators, when the denominators are the same in subtraction or addition, what you do is you just add the numerator and the denominator remains the same, or if you are subtracting, you just subtract the numerators and the denominator stays the same. Okay, if you look at the exercise down there, now you have two operations in one expression. Now what do? You have to follow BEDMAS. Addition comes before subtraction. Now what you need to do there, just follow the steps of addition of fractions. Make sure the denominators of the two fractions that you are adding have the same denominators by simply multiplying the first two fraction with the numerator of the second fraction, and then the second fraction multiplied by the numerator by the denominator of the first fraction, and then you will see that your denominators are the same. When the denominators are the same, then you can just add the numerators. When you are done and you have a single fraction, then you can move on to subtraction and you do the same. When it comes to multiplying of fraction, this is the easiest of them all. You just have to multiply the numerator with the numerator, denominator with the denominator, simplify if you can. Let's look at step 3. It says simplify the fraction. You have 2 over 10. How can you simplify 2 over 10? 2 can go into 10 5 times, isn't it? But in itself, it goes 1 time. So you can simplify that to 1 over 5. 2 going into itself 1 time and into 10 5 times. Okay, then we move on to division of fractions. Division of fraction is also simple. What you do is you reciprocate the right hand. Is it right? Yes, the right hand side fraction. The numerator becomes the denominator and the denominator becomes the numerator. Then the division signs change to multiplication. When the division sign changes to multiplication, then you can multiply the numerator with the numerator, denominator with the denominator. Simplify if you can. If you cannot, leave it in the way it is, but do not change it to decimals. Let's quickly move on to equations. An equation is a statement that states that two things are equal. Whatever is on the right, it's what is on the left. Okay, now let's say, for example, we have an equation that says 4x plus 2 is equals to 16. Now this is an equation because the left hand side is said to be equals to what? Equals to the right hand side. Now how do we call this 4? How do we call the x? How do we call the 2? And how do we call the 16? 4, because it's multiplied with the x, which is an unknown variable, then we call 4 a coefficient. Okay? And then the x is a variable. 2 does not have x or y attached to it or multiplied by it, then we call that a constant, as well as 16 is also a constant. How do we solve simple linear equations? Why do we say these are simple linear equations? Because they only consist of one unknown variable. And you can solve for that unknown variable so that your statement will become true. You say if the left hand side is equals to that and the right hand side is equals to that, then what is the value of x, so that the right hand side will be exactly equals to the left hand side. The first example there, a simple one, 5x plus 2 equals to 17. We can see that we have a coefficient of 5 with its variable x plus 2 equals to 17. Now 5 is the coefficient, x is the variable that is unknown. Now we need to solve for the unknown variable. Now how do we do it? We have to collect like terms. How do we collect like terms? All the terms that have x, bring them on one side. All the constants that does not have variables, you bring it on the other side. Now we are going to take 2 on the other side of the equation. Now whenever a number crosses an equality sign, we say it will change the sign. Okay? On the left hand side is a negative. When it goes to the positive side, I mean to the right hand side, then it becomes a negative. So a positive 2 becomes a negative 2 on the right hand side. Then we have 5x is equals to what? 17 minus 2, which is equals to 15. Now 5x is equals to 15. We still want to know what is the value of x. Now how do we get the value of x? We have to get rid of 5. Now, since these are two products, 5 and x, for you to get rid of the 5, you have to divide it by itself so that it becomes 1. Okay? Because we know that when it becomes 1, we don't write 1x, but we know it's just x. So if you do that on the left-hand side, you should also do it on the left-hand side. If you do it on the left, do it on the right, so that you don't change the equation. Now 15 will also be divided by 5, then we will find that x is equals to what? Equals to 3. How do we know if this calculation is right? You substitute 3 in the original equation. So you multiply 5 with 3 and it will give you what? 15. It gives you 15, you add 2, it gives you 17. 17 is equals to 17. The right hand side is equals to the left hand side. So we know that our solution is correct. In the second one, we have 2, which is multiplied by the bracket, and is equals to 5x plus 1. Now we have to open up the bracket. That 2 multiplies everything that is in the bracket. Then we are going to say 2 multiplied by x is 2x, 2 multiplied by 3 is 6. Then the right hand side is 5x minus 1. Now we can see that 2x and 5x, they have something in common, which is the x variables that are attached to them. So they become like terms. You bring them on one side. You can either put them on the left or on the right. It will still be, your solution will still be the same. Okay? Now if you do that, you'll see that your answer will be equals to what? 7 over 3. Now some of you, when you get 7 over 3, you want to change it to decimals. Now when you press that on your calculator, it might give you the whole calculator display is full, and you will want to round that off. If you round it off, then your answer will not be exact of what it's supposed to be, but it will be something closer to that. So I advise you to leave your answers in a fraction form. Okay? And then we move to example 3. Example 3 is quite interesting. Some people do not like working with denominators. So if you have something that has a denominator, just get rid of the denominator. How do you get rid of the denominator? By multiplying the 4 throughout the whole left-hand side and the whole right-hand side. Then you see that that 4 will disappear and your answer will be equals to 64 over 3. We move on to algebraic expansion and simplifications. Sometimes you are asked to simplify algebraic expressions. Okay, let's say for example, what they want you to do is to simplify, collect all like terms and leave the expression in the simplest form. You have 3, open bracket 3 plus 4, close bracket minus 5, open bracket 5 minus 2. Okay, open up the brackets, you'll have 3x plus 12 minus 5x plus 10. You can see that the 3x and the 5x have something in common, isn't it? Which is the x. So you factor it out, you put it outside. What is remaining is 3 minus 5. If you open up the bracket, it will still take you back to 3x minus 5x. Okay? Then the 12 plus 10 is a constant. You can add them together and that will give you 22. Now in brackets that you have factorized, or you have factor out x, you have 3 minus 5. Those are two constants and you can subtract them easily and it will give you a negative 2. So at the end of the day, you only have a negative 2 multiplied by x plus 22, and that is your final answer. Can you collect any other like terms? No. You only have a coefficient of negative 2 and the variable x plus 22, and there's no common terms there. So your answer ends there. Okay, number 2 looks quite long, but it's very simple. You just have to follow the steps. I have given you an exercise that you need to do. I hope you know anything that is raised to the power of 2 means that you are multiplying that exact thing 2 times. Just like we have 4 to the power of 2. 2. We know what that means, isn't it? It means 4 multiplied by 4. But on your calculator, you can easily get the power 2 on your calculator and just press your calculator and get the answer. But this one, for simplifications, you will not be able to do it on a calculator straight away. We quickly move on to simultaneous equations. Simultaneous equations are equations with two unknown variables, and the powers of the unknown cannot be greater than 1. That makes it a simple simultaneous equation. Now we solve these two equations with two unknown variables at the same time. Okay? The two methods of solving is elimination and substitution. In some in the exams or in the assignments, you are given instructions. Use elimination. If substitution is what is simple to you and you are told to use elimination, you have to use elimination for you to get your full marks. If you do what is not asked to be done, then you are going to get no marks for that because you are not answering the question. Okay? Let's quickly look at how we solve simultaneous equations by using the method of elimination. Let's say we have 2x plus y, which is equals to 7, and then we have 3x minus y, which is equals to 8. Now remember, to eliminate is to get rid of something, isn't it? Okay, let me just pull it down so that you can see. Okay, to eliminate something means to get rid of something. Now for you to eliminate a variable, it means the coefficients of that variable should be the same. Now this example that we picked is a simple one. We can see that the coefficient of y are the same, so we can just eliminate. But if they were not the same, let's say we want to eliminate x variable, then the coefficient of the first x and the second x are not the same, so we cannot eliminate them. We have to make them the same. So how do we make them the same? We are going to multiply the first fraction with the coefficient of the x in the second equation. I hope I did not say fraction. And then we multiply the second equation with the coefficient of x, so that if you multiply 2 by 3, you get 6x. Multiply 3 by 2, you get 6x. Then the coefficients will be 6, 6, and then you can eliminate. But let's eliminate y because it's simple. The coefficients are already the same. Now to eliminate these two, you have to add. Now most of you will be surprised, why am I saying you are going to add? Okay? If you say y plus a minus y, that is the only way it will disappear. Okay? You will get 0. But if you just say y minus y without taking into consideration this positive here, then it means with all the other terms you are going to subtract. But if you are going to subtract the other terms, that is not correct. Your answer that you are going to get is not right. But if there's any method that you know how to use and is very easier for you, you don't need to follow mine. Just make sure your answers are correct. Okay? Then we are going to have 2x plus 3x. That will give us what? It will give us 5x. Then y plus a negative y, it will give us 0. Okay? Then 7 plus 8 will give us what? It will give us 15. Now we have 15x, which is equals to, not 15x, but 5x is equals to 15. Then we divide by 5. We divide by 5 because we want to get rid of that 5 there. Then we'll see that x is equals to what? X is equals to 3. Okay, now that we know our x is equals to 3, we are going to substitute x in either the first equation of the original or in the second equation of the original. But in either of the two, your answer will still be still the same. Okay, remember we got our x to be equals to 3. Okay, and then our original equation, the first one was 2x plus y is equals to 7. Now in place of x, you should put 3. Then we have 3 multiplied by 2 plus y is equals to 7. Then this will give us what? It will give us 6 plus y equals to 7. Collect like terms. If we collect like terms, then our y is going to be equals to what? 7 minus 6. Because it crosses the equality sign, the sign will change. So y is equals to what? Y is equals to 1. Now if we substitute it into both x equals to 3 and y equals to 1 in our original equation, we will see that our answers are correct. Now both the answers should be correct. The solution that you got, if you substitute it in the first equation, it should give you the answer, which is 7. If you substitute it in the second equation, it should give you the answer of 8. If not, if it only works in one, it means that solution is not correct. Okay? And there's only two, which is a pair, one unique solution to each simultaneous equation. Our answer for x was 3. So 2 multiplied by 3 is 6 plus 1, which is y, is equals to what? Is equals to 7. Then 3 multiplied by 3 is 9 minus 1. Then it gives us 8. Then we can see that our solution is correct. Then we move on to substitution very fast. We are going to use the same equation, 2x plus y equals to 7, and then 3x minus y equals to 8. Now in substitution, the first step that you should do is to either make x or y subject of the formula in either the first equation or in the second equation. Now if you use the first equation, substitute the value of y, the new value of y, which will be in terms of x, into the second equation. Let's say we want to make y in the first equation subject of formula, then y will be equals to what? 7 minus 2x. Okay? This came from the first equation. Now substitute in place of y in the second equation. Substitute 7 minus 2x. Then we are going to have 3x minus, let's put it in bracket, minus 7 minus 2x equals to 8. Now what I have done there, I've substituted the new value of what? Of y into the second equation. Do not substitute it in the first equation because this came from the first equation. So you should use it in the second equation for your answers to be correct. Okay? Then we open up the brackets. You have 3x minus 7 minus 2x minus 2x. It will be positive now because this is a negative, plus 2x is equals to what? Equals to 8. Then you have 3x plus 2x is equals to what? 8. 7 goes on the other side, plus 7. Okay? Then we have 5x is equals to what? 15. We divide by 3, divide by 3. X is equals to what? X will be equals to... We are not dividing by 3, but we are dividing by 5 so that it cancels. Divide by 5 so that it also 15 divided by 5, it will give us 3. So our value of x is equals to what? Is equals to 3. If we substitute it in either of the two equations, then you see that your y answer will be equals to 1, and that is what we got when we used elimination. Okay? We move on to quadratic equations. Quadratic equations. This is a second order polynomial, and the highest power there is 2. Okay, that is quad. And then a, b, and c are known variables, but a can never be equals to 0. Okay, let's look at the examples that are there. We have 2x to the power of 2 plus 5x plus 3, which is equals to what? Which is equals to 0. What is the value of a? The value of a is what is the coefficient of x to the power of 2, and that is equals to what? 2. What is the value of b? Value of b is 5, the coefficient of x. And then what is the constant that we have there? The constant is 3. So that is the quadratic equation. If a becomes 0, then the equation is no longer quadratic, but it becomes linear. That's why we say there's a restriction of saying A can never be 0. There's a mistake on the slide. 2 methods of solving. There are not 2 methods, but there are 3 methods of solving quadratic equations. We only use 2 for the certificate level, but for the degree level, we add another one that makes them 3. Okay, factorization using quadratic formula and completing the square method. Those are the 3 methods on how you can solve quadratic equations. Some of these things you can Google. Factorizing method of quadratic equations on Google. You get YouTube videos that you can watch, and that will make your studies easier for you. Anything that you can see there can be watched on videos on YouTube. Okay? When it comes to factorization, there's 2 cases within the factorization method. When A is equals to 1 and when A is greater than 1. The way we factorize when A is equals to 1 and A is greater than 1 is not the same. But there are some simple rules that I've written down for you in the slides. You can pause and watch it over and over. They are really simple. For when A is equals to 1, you can just find the factors of C. Now these factors of C, when you add them or subtract them, they should give you B. So that when you take these 2 factors, you replace them in place of B, so that your equation will have 4 terms, so that you can simplify using grouping 2 by 2. Okay? Let's look at an example. We have x to the power of 2 plus 3x minus 4, which is equals to 0. We have to look for the factors of what? The factors of 4. The factors of 4 is 1 multiplied by 4 and 2 multiplied by 2. Those are the only factors of 4. Factors of a number is then the 2 numbers that you multiply, and it will give you the result of that number. Okay? Now we want 2 factors that can break down 3. What am I saying here? We are saying in the factors of 4, look for the 2 factors. You multiply them, you get 4. But when you add or subtract while changing the sign, it should give you 3. And those factors are 1 and 4. If you make 1 negative and then the 4 remains positive, then 4 minus 1 will give you 3. If you put x attached to all the coefficients, you have x minus x and you have 4x, then you say 4x minus x, it will give you, okay, we are not looking for a negative value, but we want a positive, which is 3. So 4x minus x will give us 3x, and the 3x is what we have there as b. So instead of writing 3x, just write it as 4x minus x, and then that will be easier for you to factorize. Okay? But when a is greater than 0, when a is greater than 0, you find the factors of AC, not the factors of C. There's a slight mistake there. The step 1, find factors of AC. A multiplied by C. Okay? Then those the 2 factors that you choose should still be able to give you B. Let's look at an example. We have 6x squared to the plus 5x minus 6, which is equals to 0. Our A there is equals to 6, and that 6 is greater than 1, isn't it? So you look for the factors of AC, and the factors of AC are what? The factors of AC, C is equals to 6. So this is 36. 6 multiplied by 6. 6 multiplied by 6 will give you 36. Now look for all the factors of 36 and find one that can give you 5x. 4 multiplied by 9 is 36, but 9 minus 4 will give you 5. So instead of writing 5x, just write 9x minus 4x. For clarifications on these things, you can call me on the numbers that are provided on the screen so that I can assist you further. Completing the square. Will not be able to go through that one, but I've given all the steps in the slides, so you can pause and then read on the slides. And remember, if you have a question, you know what you should do. But most of you don't call. But it's fine. Make sure you understand these things so that you'll be able to tackle them in the assignment or in the exams. All these things will be there for you to read, go through, seek for help from your friends, your neighbors, so that they can help you on some of the things that you do not understand. But everything in these slides are very important for your assignment and also for your exams. This is almost everything that comes in your course outline. Please watch the space. You can watch some of my videos that I have done on IOL. The subjects that I've done are quite similar to one another. So some of the topics that I've covered in here, I did not cover them in the other mathematics. So just look at your course outline and follow my slides. See if there's anything that applies to your course or to your module, and then read further on them. Thank you very much. Until next time.